Hey guys, this video is going to be super short because we have already learned our prime factorization parts, and we have also already learned what we need to about exponents. So now we're going to kind of combine these together, and it is going to be easy for you if you understood how to do the factor tree or the long division model, and if you understood exponents, today will just be easy because we are combining those two. So there's no steps, no vocabulary. We've already learned both parts. We just need to combine them together now, and I want to give you a chance to do a couple of examples. So our first example that we are going to do, don't forget to start a new page in your math journal. I've kind of set up my Cornell notes here, number your page, and make sure it goes into your table of contents. Okay, so our first example here, I'm going to use red. I am going to do the number 28. So if we're doing it the factor tree way, we're thinking of two numbers that multiply together, which that part is easy. We could either do 14 and 2, or we could do 7 and 4. So I'm going to do 7 and 4. Now remember, as soon as we see that the number or numbers are prime, we circle them to show that we found a prime number. So that one is prime, but 4, I know that 2 and 2 can multiply together to get 4. So now I circle those because 2 and 2 are prime. Now, in our lesson a couple of days ago, you wrote this out as 7 times 2 times 2. This is where it changes because we have a duplicate. This set of 2's right here, we are going to combine those with an exponent. Because remember, an exponent tells us how many of that number there are. So instead of writing it like I have right here, I'm going to do 7 times 2. And then how many 2's are there? 2 of them. So I add an exponent. So my final answer that combines prime factorization and exponents, my final answer here, instead of 7 times 2 times 2, is going to be 7 times 2 squared, or 7 times 2 to the second power. It's very, very easy. If you are good at the factor tree, all it means is at the end I circle any of my numbers that have duplicates, and then it's easy from there. So I will do one more example over here. And if you want to try and start working ahead because you think, okay, I got this, I can try it, then go ahead and challenge yourself to work a little bit ahead here. I'm going to do a bigger number here. Let's do the number 72. So on this one, that was not what I wanted. We're going to do the number 72. And I always do it factor tree way, but if you do it the long division way, then go for it. You keep doing that if that's what you like. Okay, so 72. First off, I'm thinking of what prime numbers could go into this, or what two numbers could multiply together to get it. It doesn't have to be prime. But 72 is a really big number, and I'm just not sure about it. But I know that it's even. So if I know it's even, that means that 2 times something gets 72. So even if you're stuck on an even number like this, you know you can pick the number 2. Now I just have to figure out what half of 72 is. So let's see here. I know 35 times 2 is 70, so it would have to be 36. So I have 2 and 36. Ooh, okay, so I like 36 because I know that 6 times 6 is 36. I forgot to circle my prime up here. So now 6 is not prime, so I need to break it down even further. So I'm going to break this into 2 times 3, and same thing right here, 2 times 3. And look at here, we have our prime numbers at the end. So now it was a couple days ago, we would have written this final answer as 2 times 2 times 3 times 2 times 3. Now that's really, really long, and we haven't combined our numbers that are duplicates yet. So we need to combine these ones that have more than 1. Now, I know I have 2, and I know I have the number 3. So now I just have to count how many of them there are, because there are 1, 2, 3 2's. So that means I have to put 2 to the third because my power tells me how many there are, times 3 to the, let's see, there's 1, 2. So 3 squared. So see, it just makes my final answer look so much prettier. It adds that exponent so that I don't have this huge, long, expanded answer. I can condense it a little bit with these exponents and any numbers that are duplicated. Awesome. Well, this was a nice quick one, you guys. If you would like to try some more on your own, feel free to do that. I'm actually going to write some over on the side. If you're wanting to try another one on your own to see over here, a good number would be the number, let's see. The number 50 would be a good one to practice on. It's not super long. So if you wanted to try one, I would go ahead and try this one and see if you get stuck on anything. And then I can answer any questions that you have tomorrow in class. And this will be, again, a pretty easy day. We should be able to get all of our work done in class. So have a wonderful rest of your night, and you are set.